Welcome to this video where I'm going to show you how to get Docker working on macOS. So the first thing we need to do is to make sure that Docker is actually running on our computers, that the Docker engine is running. So assuming you've installed Docker, go into Applications, click on Docker. That will open up the Docker application itself, and it will also start the Docker engine. And it can take maybe a minute or so for the engine to get started, depending what setup that you've got. This computer is pretty old. So you can see the Docker engine is starting, and the little wheel logo has appeared up here. So we're going to be interacting with Docker using the terminal on Mac. Maybe it's something you've used before, maybe it's something you haven't used before. To get the terminal, you can go into Applications, Utilities, and then click on Terminal. When the window opens up, it's maybe a little on the small side. So if you press Command+, it'll make the text larger. So we've got our terminal here. So this is how we're going to use Docker, how we're going to interact with it. So to make sure that Docker engine is up and running, we can type Docker and then version, which will tell us the version of Docker that we have installed. We see here we've got Docker version 20.10.8. So we're going to run our first Docker container using the Hello World Docker image. If you don't have the Hello World image on your machine, which you won't have if you haven't used Docker before, when you first try to run it, it will realize it's not on your machine and then go and download it from Docker Hub, which shouldn't take more than 30 seconds or so because it's a pretty small image. I've already got it downloaded, so if I type Docker run hello world, it'll run a little program in a Docker container that will basically tell us that our installation appears to be working correctly. And basically, you've actually just run your very first Docker container. When you use Docker, if you use it regularly, you'll find yourself building up a number of different Docker images on your computer. Some of these are titchy tiny in size. Some of these are a little larger. If you type Docker images, it'll list all the Docker images that are currently on your local machine. You'll just have the one at this point, the Hello World image. I've got quite a few, some from a couple of years ago, some from just a few days ago. So you can kind of see the Hello World image is just 13.3 kilobytes, so incredibly tiny. But some of the other images I use related to Python and R, we're talking sort of 3 or 4 gigabytes. So your computer can fill up quite quickly if you're downloading a lot of Docker images. I've probably got about 15 or 16 gigabytes worth of images running on this machine. So we've just run the Hello World Docker image. You've got this container running. It's, not particularly impressive. It really just checks to make sure that everything's working okay. So what we're going to do now is we're going to run the Rockerverse Docker image. We're going to run that container, which is a pre-built Docker image that contains RStudio, and a whole bunch of tidyverse packages. So we're going to type docker run --rm, which will shut down the container once we quit our browser, -p, which sets the port on our computer that allows us to interact with the Docker container using our web browser. I'm just going to set a password to be as an environment variable, as a straightforward password, as a password in lowercase, and we're going to run the Rockerverse. So when you click return, it could take potentially 10 to 20 minutes for all of the different layers of the Docker image to be downloaded onto your computer. You only ever have to download it once. Once your Docker image is downloaded, it'll be quick to get up and running next time. So if I press return, I've already got the image in my machine. So we now have our Docker container running, but we can't see anything. We need to interact with our Docker container using our web browser. So in this case, we're not using our web browser to access the internet. We're using our web browser to access the port on our computer at which our Docker container is running. So if we go down to Safari or any other web browser and open it up, and we type in the address, localhost, :8787, press return, we get connected to the Docker container on our machine that's running RStudio. So the username to log in is simply the name RStudio lowercase, and password is the word password in lowercase that we set when we first launched our Docker container. So if we press return, we see we have got our version 4.1.1 running in RStudio. If we click on packages, we can see we've got the Tidyverse packages version 1.3.1 running. We can interact with R, exactly as we would as if this was RStudio running locally on our machine. Remember, this is actually RStudio that's inside our container. So we're actually in our Docker container now running things. We could write a little script, whatever library, tidyverse, something like that. That will obviously load the tidyverse. Now, one of the downsides as to how we've set things up so far, and this might be familiar to you when you think back to when we looked at Binder, is that we can write a script up here, we can run it, but we can't save it. So in other words, we're working inside our Docker container and we're completely isolated from the rest of our local environment. We can't access any of the files on our computer, and that's obviously a real limitation. But we can easily get around that by launching or relaunching rather the Docker container so that it's connected to our one of the directories on our local computer. So let's just shut down this Docker container by pressing Control-C. That will shut down the Docker container. We're now going to do a bit of navigating using the terminal and Unix commands for navigating the terminal. If you've never used a terminal before, this will be new to you. Don't worry. We're just going to look at a couple of commands. We're going to look at the command ls, which will list all of the files in the current directory. So we've got a whole bunch of files there. And we're going to use, you see I've got a directory called UFO. So we're going to change to the UFO directory. So CD is change directory. So CD UFO. Press ls. And we now see in our UFO directory, we've got two files. We've got ufoscript.r and ufo.rproj. So this is the UFO script from way back in week 1 or week 2 of the course where we first started using R. So what we want to do is now set up our Docker container, so it's running on our machine, but we want to set it up so that within our Docker container, we can also access the files in our current working directory. So we do that by typing docker run -rm -p. So this is just what we had previously. And then we're going to use a new flag called -v for mounting a volume. And we're going to say that we want to connect our current path to our working directory to this directory here, which will be within our Docker container. And then we're going to set the environment variable as we did previously. And we're going to run the Rockerverse image. So let's press return. So it's all up and running. Again, obviously, we can't see anything until we connect to our Docker container. So let's connect. And when R and RStudio fire up, hopefully you will see, just ignore that. Just close that. Hopefully will you see when you click on files that we can access the UFO script and the UFO.rproj file as well. So you can see we've got these files on our local machine that we can now access from within our container. And it's telling us up here that Patchwork isn't installed because Patchwork is not part of the tidyverse. So we can just click on install, and that will then install the Patchwork package. Okay, so it's just going to go through that installation now. Okay, so this is pretty cool because we can now access everything that we have in the working directory of our local machine that we specified. And we can actually write locally as well. So let's create a new file. Just going to call it test script, and it's just going to do something like print. This is a test. And if we were to run it, it'll be very exciting. It'll just say this is a test. But importantly, we're now going to save it. We're going to save it, and we're going to call it test.r. So remember, we're inside our Docker container now, but we're going to write this file locally. Okay, so press test.r and save that. And we see over here that test.r has now been saved. But you might not be convinced that we've actually created this file on our local machine from within our container. So what we're going to do is shut down our Docker image, Control C, and then we're going to press, we're going to type ls, and we're going to say we now have a new file, test.r, which is exactly the file that we created when we were in our Docker container. So this is a really, well, I think this is a really nice demonstration of the power of Docker. You can actually, if you're in an organization, if you're in a research group, you might find yourself using the same Rockerverse image as everybody else in the group. And you can put yourself working within that Rockerverse container, but you can access data files, scripts, everything else on your local machine. So it's a really good way in an organization to make sure everybody is using the same sort of setup. So that's just a very brief demonstration there of how we can kind of set up Docker so that it runs a Docker container that allows us to interact with our machine. So what we're going to do now is we're going to go back to the Rockerverse container that we were just running that was connected locally. I'm going to start that up again. Open the web browser. Just need to log back in. And you saw that we had to install Patchwork, for example. If we look at the packages, so Patchwork won't still be installed because we didn't actually then update that Docker image. So how would you change the Docker image so that you're able to add packages to it and then resave that image? So what we're going to do in this example is install the Gapminder package. So we're going to do that as we normally do. Gapminder, press return. So within the Docker container that we have running now, we have the Gapminder package installed. So if you go down here, you see there's Gapminder. Just click that and that'll load it into the library. So what we're going to do is update our Docker image so that it also has Gapminder installed, so that when we start that Docker image, it's already got this new package in it. So we're going to open up a new terminal window. Let's make it a little bigger again. And if we type docker ps, that will tell us what container is running. So this is the Rockerverse container that we just created. Now what we can do is basically take this running container, which has now got Gapminder in it, and create a new container that's Rockerverse plus Gapminder. So we can do that using the docker commit command. Commit. I'm going to add a message, and I'm just going to call it verse plus Gapminder. So it's Rockerverse plus Gapminder. We then need to specify the container ID. So double click or highlight that, copy it, paste it there. That's the container, and then we're going to call it verse gap, not gamp, Gapminder. Okay, so now if we're to type docker images, you see now that we have got a new Docker image called verse Gapminder created 5 seconds ago, which is basically a combination of the Rockerverse image plus the Gapminder package. So if we were to shut down the container that we created, just quit that. And now we're going to fire up not the Rockerverse image to create a Rockerverse container. We're going to fire up our new one, which is, we call it the verse. What did we call it actually? Let's see. It was verse_Gapminder. So let's get our image that we just created, verse_Gapminder. Start that. Connect to it via our browser. Click on packages. Let's go down. You can see that we've now got the Gapminder package installed already. Okay, so we've basically fired up this new Docker container based on the first Gapminder image that we created, which has got this Gapminder package already installed. Let's just shut that down again. So, okay. So in the next video, I'm going to show you how you can create Docker files to create your own Docker images. So far, we've looked at getting the Rockerverse up and running. We've looked at how we can connect a Docker container running the Rockerverse to our local computer so that we can read and write files to our local computer. And we've then looked at how we can kind of update the local Docker image that we have so that it's able to incorporate any changes in terms of, say, new packages or anything else we've brought into the Docker container and save that as a new Docker image. So as I said, next video, we're going to then focus on how we create our own Docker files so that we're able to package together, version of R, version of packages that we're using alongside scripts that we might have written or data so that we can share that Docker image with others, or we can use it ourselves on other computers that we might have.